record. Alright, so before I was planning on going over something in Simulink, going over basically like a differential equation with all of you so you can get at least an intro to how that goes in Simulink to solve a differential equation graphically versus analytically by hand. But what's more relevant, I guess, would be the project, right? So we're going to go over some stuff for the project today instead. And so we're going to go over a lot of the stuff as a class. Well, I shouldn't say a lot, but some of the stuff as a class. And then if we have time, we can kind of have some of you ask questions if you have any, and then we'll try to answer those, okay? So before we do that, we're going to talk about a few things on the project, again, just to kind of reiterate some stuff. So we're going to do that. And then also I want to have a reminder too that SOQs are due by this Friday. So make sure that you fill out the SOQ, sometime, either if you didn't do it yet, do it sometime today or sometime before Friday. Okay, let's see. Before we start looking at the deliverables for the project, are there any questions about really anything for the class? No? Okay. Okay, so let's look at the project deliverables again. So when I first uploaded this, I forget when it was now. It's been a while, but when I first uploaded it, I had one update for this. I only updated it one time. I think it was right around when I actually first uploaded the first document, but just make sure that you have the most recent document. I'm not updating this at all anymore. I only updated it that one time. I forget when it was again, but make sure you have your document that shows the top 7 most populous counties. So that was the only thing I changed in the update. So just make sure on your deliverable handout it says top 7 most populous counties. And if you're wondering why it's 7 and not, it seems like a kind of random number. Basically, 7 is the maximum amount of unique colors that MATLAB has by default when you plot something. So of course you can plot more than 7 things at once, but then the colors for the plot, they start to kind of like repeat again. And you could have unique colors, even more than 7. But for that, it actually, your code gets a little more complicated. So we're just going to keep it as 7 counties. All right, so hopefully all of you looked at this handout, by now. It's been up for a while, so hopefully you looked at it. But I want to reiterate a few things. So actually, I guess we'll just kind of briefly go over the entire thing again, just to kind of refresh you and see if you have any questions again. Okay, so for the project, it's going to be like project 1, of course, but this time we have looping instead. And we're only going to be looking at data for the counties. So we have 3 spreadsheets. We have one for the population for all the counties, which is called Cali County Pop. And then the other spreadsheet is statewide cases. So that's what we had in project 1. That'll give you data for the cases and the deaths for all of the counties. And a new spreadsheet that we have this time is hospitalization data. So that's pretty similar in formatting to statewide cases. It's just a different spreadsheet that's provided. Right, and then important dates, it's going to be due on the 20th, so that's after all of your finals. So I think that's a Sunday. So yeah, so you can, do all your finals first, and then you can finish up your project. Hopefully you're not just starting your project after your finals. That would not be a good idea. And then the date for the data upon submission, so basically the spreadsheets that you're using, make sure that you're using the December 16th. So I'm going to upload that as soon as it's available. And of course, your code, it should run right away once I give you this spreadsheet. So once you download December 16th, you should be able to just put that in your directory where your script is and just run your script, and there should be no issue with the updated date. So remember, your project, part of it is graded on whether you did hard coding or not. So make sure you're not doing hard coding. In this case, if you're not doing hard coding, you can just run a script right away for new data. Okay, report structure. So I got all of this laid out again. So this is the formatting for the report. It's a little different than last time. I changed a few things around, but we have our intro, and then we have the results and write-ups. I already talked about some of this before, so I don't want to talk about it too much. Make sure you do your write-ups right. So that's where a lot of people missed out. I shouldn't say a lot, but that's where some people missed out on points for the first project. To make sure you have all of these write-ups, make sure that they're detailed. This is a big part of the report. Okay, and then this time your appendix, that's where you're going to include all of the figures. So all the figures that you need, they're laid out right here. So we got 14 in total. That's a lot, but some of these figures are just basically adding on one new thing and basically just a new line. Like if you look at 5, 6, and 7, it's a confirmed ICU patients, and we're just adding on one new thing in these in 6 and 7. So it's not really as bad as it looks. And then at the very end, copy and paste your code, just like you did the first time. Grading breakdown, make sure you take a look at this. This is kind of what I'll be looking at for kind of like a metric for all of your projects. Required for loops, make sure you take a look at this. So I'm going to make sure that you use the for loop for all of these things. And really you would have to anyways to get all of them. If you're going to do it line by line like the first project, you would have like 60 lines of code to do some of this stuff. So a for loop is going to be necessary anyways, but make sure that you have all of these for loops here. Okay, and then the recommended attack plan. So I'm not saying this is what's happened, but I get the feeling that some of you've worked on the project so far and you have started with your own, I don't know, I guess workflow, which is good, but this is basically showing you almost everything that I did for at least the first part of the project for the statewide cases and deaths, and really for the second part of the project, it's very similar for the workflow for what I did here. So I would take a look at this because this is, it's going to work if you do it this way, basically. And we're going to be going over some of this today, actually. So not everyone's here. There's actually not too many people here. So I guess some people are missing out. Okay, so take a look at this. Again, I really recommend that you look at the recommended attack plan. That'll help out. And then our plot format requirements, that's the last thing here. So take a look at that as well. All right, so also there's been a few questions on using salaries for plotting. So I know myself, I ran into an issue before. If I was trying to plot multiple things at once from a salary, you can kind of run into issues. So in that case, I'd recommend using a table instead for that unique data. So if we have a salary that contains data for cases per day and deaths per day, I would instead make a table that has all of the cases per day in a separate table, a table that has all of the deaths per day. And then you can plot that easier that way. But again, I would recommend looking at the recommended attack plan because how I formatted everything in here is how exactly my code is kind of laid out, and I can make all the plots that way. Okay, Question, should we have a table for each figure? You don't need to have a table for each figure. I don't have a table for each figure, so I have a table for cumulative stats, which we'll go over a bit today. So all of that I can have in a table because it's just a scalar for each value in here. But for the rolling stats, I used a cell array for this, but within each cell, then that was a table. And so that's kind of laid out like I was just kind of mentioning. I had one table for deaths per day, and then I have a table for new deaths per day per million, another table for new deaths per day per 1 million per county for a 7-day average. So I have a cell array, but each cell has its own table. Okay, so that's similar to our homework 4 as well. Let's actually take a look at that. So I'm going to show you something as well for this, but for homework 4, let's open up actually this was a table. Okay, player events. So it's a little different, I guess, in the homework. So you see here for player events on our homework, we had a 1x61 cell, and then within each cell we had an array. So for the project, what I have for like a new deaths per day, we have a cell that'll be similar to this, and within each cell we're gonna have, it can either be an array or a table, it doesn't really matter, but you can imagine that this is a table that contains the new deaths per day for each county. So each county would have their own column. Does that make sense? Okay. And yeah, so that way it'll be a lot easier for us to actually plot everything at once. So if you're imagining that this was a cell for new deaths per day, again, each column would represent some county. Then we could just plot, the first 5 columns, or I guess the first 7 columns, and then we could plot all of those new deaths per day. All right, so something I want to talk about. I've never actually used this before, but you might want to look into this publish option for your script. Again, I've never actually used it myself, but if you run this publish thing, it's going to basically run your script. So you'll see I'm going to get my figure that's going to show up. But basically, it's formatted to show your script in a nice little way. So all of these bold portions here, those are my section titles that I have. So that's when we have 2% signs. And then it kind of, it breaks everything down into these sections that we've had it formatted as. So it could be kind of nice. The only downside is, at least by default, it doesn't show the number line for the code. So there might be a setting to change that though, but I don't know. You might want to look into it for this report, or you can just take screenshots like you did on the first report. Okay, I'm going to stop sharing my screen really quick. I want to make sure that I only share my screen for what I want you to see today. Okay, so we're gonna go over this today, so maybe I should have mentioned this before. So I know some of you, hopefully all of you, really have started on your script for the project. So maybe you want to copy and paste your current script, or maybe just want to start a whole new script, but we're gonna go over some of the coding today, only some of it, so you can kind of, I don't know, get some help or get a better idea for the kind of attack plan that I recommend you use. So again, you can either copy and paste your script or just make a new one. It doesn't really matter, but yeah, we're gonna go over some of this stuff today. So I'll give you, a minute or two to work on that. But if you have a script already open and you're ready to go, then make sure that you just have this first part here, which is basically just importing data. So we have all of this section here. So I'm giving that to you, just all of it, because it's really simple stuff that all of you should know how to do by now. And of course, if you aren't able to do it all right now in time, then you can look at it after class when I upload the video too. I don't want to, take up too much time. Okay, so while you're working on that, I'll kind of talk about this too. So we're just importing data, of course. So the first part here, also take note of the comments that I'm using throughout. This is what I want to see, at least something similar to this when you actually upload your code. So the first project, I think every single student besides one student didn't have enough comments throughout. So format your comments kind of like I'm doing here. I have a lot of comments throughout. Okay, so the first part, we're just importing the population data. So to do that, I made a variable called calipop, and we use our read table function, and we can import all of the population data. And then on the line below, I could have even had a comment for this, which it would be convert county names from a cell to a string. Right, so for that, again, we're just, what I just said, we're converting a cell to a string for all of the county names. Now, below this, I'm copying a calipop for the hospital. So remember, we kind of have two sections for this project. The first section is the statewide cases and deaths, and then the second section is the hospitalization data. So for that, I'm going to copy the calipop spreadsheet that I made up here, and I'm going to have a new one that's called hospitals calipop. So I'm doing that because later on in the code, we're going to delete some counties for the statewide cases and deaths that don't match the length of the testing range. And we're also going to delete some counties for the hospitals that don't match the testing range for that. So when I say testing range, that means the very first date that's available in that spreadsheet for the testing to the very last date. So some counties, they didn't start their testing as soon as other counties. And because of that, the length of their kind of testing data is different. And because that length is different, we can't plot all of those counties at the same time because those vectors need to be the same length. So to just easily address this issue, we're just going to delete the counties that don't have that entire testing range. Now, there's only a few of them, like maybe 2 or 3, so it's not too bad, but we're just doing that to make the project a bit easier. And then same thing with the hospitalization data. That testing range is actually different than the statewide cases, so that's why we have two different spreadsheets that we're using for the testing range, basically. And so different counties are going to be deleted from the hospitalization data. So again, we'll kind of talk about that a little more too, hopefully if we have time. Okay, and then the next thing is importing the cases and deaths. So all of this should be familiar. I also sorted the rows here. This sorts it alphabetically by the county name. And then the last part is importing the hospitalization data. And then we're sorting that alphabetically as well. And then we're also converting the county name from a cell to a string. So what I'll first do is run this. Okay, hold on. I'm gonna exit this. Okay, good. My color scheme is weird. That's okay. I'll just leave it. Okay, so I'm going to show you the workspace. So let's, oh, actually, I can't show you that right now. Okay, let me stop sharing really quick. I have my actual script on my screen as well, so I just need to make sure that I'm not sharing that, of course. Although I'm sure some of you want me to share that, but it's not going to happen. Okay, I'll do this really quick. Okay, let me share my screen. So I'm just going to show you the CaliPop spreadsheet. So this is for all of the counties that we have. Move that out of there. Okay, and you can see that it's sorted alphabetically. So for the hospitals and the counties, again, some of the counties that we're going to delete for the statewide cases and deaths, they're going to be different than some of the counties that we delete for the hospital data. So just keep that in mind. And yeah, okay. I guess I didn't really need to share this right now. Okay, I'm going to get my script back in here. Okay. Okay, so let's go on now. So the first part is the data reduction. So we're going to start, the first section is going to be the statewide cases and deaths. That's what I did. So if you look at my deliverables handout, you'll see that everything I'm doing here is actually in the recommended attack plan. So all of these lines of code should be in there. And it's pretty much every line of code besides a few. So sometimes I might see on the handout to like, let's actually pull that up. Oh, I deleted it. Or I didn't delete it, but it's not up anymore. So sometimes I might say to do something, and there might be multiple lines of code that you actually have to write. But basically, I tell you each step in the recommended attack plan that I did. Okay. So the first thing is plot parameters. So we have a line of code here for the amount of counties to include in our plot. So remember on the handout that I changed that a while ago to 7. So we're going to specify to use 7 counties. And this is just so we don't need to do any hard coding later on for the actual plots. So I'm just going to do counties include equals 7. You can call it whatever you want. I called it counties include. Okay, no one's had any questions so far, right? I haven't heard anyone say anything. I just want to make sure like my headphones are working okay. Usually you guys have more questions.
No.
Okay. Okay, so the next thing we'll do is counties roll average. If I can type. Okay, and this is also going to be 7 because we have a rolling average of a week. Yeah, we'll get to the more meaty stuff in a bit. So right now it's pretty simple stuff. Okay, and then we have the range of testing dates. So again, this is going to be the very first testing date that we have to the very last testing date, which is, of course, whatever is the most recent date for testing. So the minimum testing date, remember, that might not be the same for all of the counties. In fact, that's not the case. So I'll do counties testing range. I'm also going to make this a column vector, so that's why I'm doing all of the rows and then one column. Likewise, you could just do counties testing range equals whatever and then just transpose it. Up to you, but I'm gonna do it like this. Okay, so we have counties testing range equals the minimum of counties.date counties.date, and then we're going to do to the maximum of counties.date. Oops, I was looking at the wrong line. Oh, we need to use a colon here. Okay. And this should be over here. Okay, sorry about that. So we have the minimum of counties.date, and then we're going to do this to the maximum of counties.date. Okay. I'm going to comment out some code here. Run this. Okay, I'm going to stop sharing my screen really quick again. I want to see if I can share just a portion of my screen. I think I saw that I could before. I can click on it, but then it doesn't do anything. And I can only share like one of, you see what's highlighted now? Or no, well you can't, I'm not sharing my screen, but I can't share both the workspace and my code at once. It's kind of annoying. Okay, hold on. Okay, well, let's just share my screen again. Almost shared the wrong one. Okay, so once we have something that's more worthwhile for looking at in the workspace, then I'll share that. Okay, but for now we're not doing anything I guess too advanced to share. Okay, so next one, we're going to do the indices for the last testing date. All right, so this is going to get the index for each county for the last testing date. So we'll do county's last date, IND for index. And then we're going to use our find function. So find, and then is member counties.date. So we're going to look at that column in our spreadsheet. And then we're going to look at max of counties.date. You know what, I'm going to open up actually just MATLAB. It's not going to look quite as nice, but it'll be better to share my screen. Okay, sorry about this. I just want to look at the workspace as well when I'm talking to you about this. Okay, so this is a lot more constrained though. Let's actually, I'm still running into the same issue. Okay, sorry guys. I thought that this would work. So once I open up my workspace, basically something in the workspace, it doesn't, show that on the shared screen. I have a solution though. Give me another few minutes, sorry. I don't want to spoil the code. No, the solution is not to show you the code. I really wish I could just share a portion of my screen, but that's not giving me the option to draw the rectangle. And I can't select multiple windows at once either. Really annoying. Okay, let me run this. Yeah, I could copy that lines into a new script, but that's not the issue. I want to show you this script that we're working on right now, and I want to show you my workspace at the same time too. But that opens up a new window on my computer, and I can't share that at the same time. So let's look at this one. I think there might be an issue or a solution here. Yeah, okay, cool. Okay, so I just have to do new share. Let's see if I stop that. No, then it just goes away. Whatever, that's an okay solution. So we'll try that. Okay, let me move this down. Okay, where do we even leave off now? So, okay, indices. Let's pull this up. Okay, so here is the indices that we just made. So we did counties last date indices, and then we did find is member counties.date to max counties.date. So what that's doing is it's looking for the most recent date of testing, and every time it sees that date of testing in our vector, then it gives us the index for that. So in this way, we can find the index for the last testing date for each county. Okay, and then that's what you see here. So for our first county, that's on index 265. So I'll also open up this county spreadsheet. So let's go to row 265 here. Okay, so 265. It's I don't know how do you say that. Alameda. I don't know. And we see our last testing date was December 7th. And then let's see, the next one is 518. We'll just check this. So we'll go to 518. That's Alpine. And then there we go. We have that last testing date as well. Okay, so that's working out for us. We have the index for each county for the last testing date. And then let's new share, go to project demo. Okay, cool. And you'll notice that I'm not using any hard coding, right? I'm just using this function, this max function, to get our latest testing date. Okay, so I'd recommend doing that. Well, of course, you have no reason to not do it now. I gave you the code for that. So do that, and then you don't have to hard code the last testing date. So I'm also going to actually make a variable just for the last testing date as well. Off the top of my head, I can't remember when I actually used this later on in the script, but I'm sure I did somewhere. So we'll do counties last date, and then I'm going to use the max function once again, and this will be counties.date. And basically this will just be a datetime vector that'll give us, in this case, December 7th. All right, and then custom starting date for our plot. So from the first project, I started a lot of them on March 1st. And we're going to do that for this as well. I haven't actually looked at the statewide cases for when most of those start. Let me check this really quick. They start on the 18th of March, so maybe this line of code is kind of pointless here. This is probably for the global data last time, so I'm actually just gonna, well, let's delete this out. Because yeah, the first data testing is March 18th. We can actually confirm this by doing min of counties.date, and yeah, it's March 18th. Okay, so we won't worry about that. Okay, so the actual data reduction part, let's get to this now. So the first thing we want to do is find, well, first we specified the non-counties. So if you remember from the first project, that was a county in quotes here called unassigned and another county in quotes called out of country. So we want to find all of those indices and then delete them. So you should already know how to do this from the first project. So I'll go over this kind of fast. I'm going to do non-counties IND for indices. Find is member. And then we'll do counties.county. And then we're going to reference this basically a string array right here. So we can look at both of these non-counties at once. And then we can find their indices. Okay, so now we have their indices. Now we can actually delete them. So to do this, we're going to do counties. We're going to use array addressing. So counties, that's the spreadsheet that we're looking at. And then we're going to use our indices that we just found. So non-counties IND. And then we're going to, we also need to put a comma and then a colon. Because our indices, that just references the row. So I want to go to the row for the indices for these two fake counties. And I also want to look at all of the columns. And then I'm going to delete them. And remember, to delete them, we'll use open brackets. So let's share my screen. Yeah,
Professor,
question?
at this point, do we also delete them from the datasheet of hospitalizations as well?
No, I'm going to do that. Personally, I did that later on. I kind of broke up my code into one section for statewide cases and one section for hospitalizations.
Okay.
Yeah, because the index for the unassigned and out of country, that's going to be different in the statewide cases spreadsheet than the hospitalization spreadsheet. So you see on line 63 here, I have find is member counties.county. If I was doing it for the hospitalizations, I would have to do, I forget what I called that spreadsheet, but it would be hospitalizations.county. Yeah, just because they're different spreadsheets. Okay, so let's share my workspace. Okay. So here we have the counties. So at one point we have, let's just go down to unassigned. Okay, so you see unassigned right there. I'm going to run our script and it just went away. I couldn't really show it at the same time, but we deleted all of those rows and columns. Okay, so now we have a line of code for finding the most populous county. So, sorry, I wasn't on my other screen. So basically, I'm just making a new kind of spreadsheet here where we're going to sort the counties by population. So I'm going to do counties underscore pop equals sort rows, and then we're going to reference our spreadsheet that contains the population for the counties. And then I'm going to sort them by I guess actually, this is kind of disingenuous. It's not the most populous counties. I'm sorting this alphabetically here. I think. Yeah, it's alphabetically. So I'll do just, let's rename this line. Sorry about that. So this is going to be sort counties alphabetically for population spreadsheet. Okay, so that sorts it alphabetically. I guess I'll show you that really quick too. Okay, so let's pull this up here. That was counties pop.
So we don't need a loop to delete the non-counties at all?
No, because that was just a vector that we made. So, oh, here, let me pull that vector up. Okay, so this was the vector that we made for the indices for the non-counties. So we didn't need a loop here, but the indices for these, they're just in one vector. So if you were looking at it, you couldn't really tell. Well, we can see here when it actually ends for the first county and starts for the second, but we don't need a loop for it. Okay, so I was showing you counties population. So you see here, I just sorted our population spreadsheet alphabetically. And now let's go into the next part. Here we go. So we're going to get our unique county names. So I'm going to do counties unique equals unique of counties dot county. So this is from our spreadsheet counties. And then you see here I have these lines of code that says counties comparison check. So this was just for me to make sure that my counties in my spreadsheet that was called counties matches all the counties that show up in a population spreadsheet. So I'll show you what I really mean here. So let me run my script. Go back over here. And I should open up counties unique. Okay. So this right here was comparing in the first column that was from counties unique, which we just made. That was looking at the unique counties in our main spreadsheet called counties. So I was looking at our main spreadsheet here, and it was getting each unique county. And then we appended the county names from counties underscore pop. That was our population spreadsheet. So I want to make sure that all of these match up. So when I reference the population later on in some of our equations that we use for the per million kind of stats, that we're referencing the correct county. So you see here all of these match up. Okay. All right, so now we're actually on, I guess, the more relevant stuff that I'm sure you guys care about, which is the looping. So for this, I'm going to skip this part here. You should be able to do these on your own. Actually, I guess I'm showing you one part here. So I'll show you that. That's finding the indices for each county. So the first thing that we're doing is we're going to do for I equals 1 to the length of counties unique. So counties unique, that basically just is for, it's giving us a length for all of the unique counties that we have. So in this case, that is 58 counties right now. But later on, we're going to delete some of these counties because remember that some of these counties, their testing range is different than others. So we're going to do that later on. Actually, I have you do that on your own, but imagine one county has a length of, I don't know, 200 for the testing range. I don't know what it is. And another county has a range of, or a length of 198. Because those lengths are different, we can't plot both of those at the same time. So we're going to delete the one that has a length of 198. So that'll make more sense once you actually look at the length of all of these counties, and then you can kind of make sense of it then. But the first thing we're going to do is find the indices for each county. So I'm doing for I equals 1 to the length of counties unique, so I can have a cell for each unique county. And I'll show you what that looks like too, of course. So we have counties unique IND for indices, and we're using curly brackets here, curly braces, so we can make a cell array. So I put a colon, but really we're just going to have one row, and then we're going to have I amount of columns, and that's going to be for each county again. Then we're going to use our find function and isMember. We're going to look at our main spreadsheet counties dot county, and we're going to put in counties unique. Remember, counties unique, that was in our case, that should be a string array for each county that we have. Let's actually check the class type for that. Counties unique, and yeah, it's a string array. So once we run this code, we can get our cell array. So I'm going to open that up right now. Just close out of some things. Okay, so remember our length here for counties unique, that was 58. So I'm going to have 58 cells. And once we look right here, we have our cell array, and again, we have 58 cells. So you can actually see the testing range for all of these counties just like this. So you see for our first county, for Alameda, whatever, that has a testing range of 265 days. And our second county, Alpine, has a testing range of 253. So if we were going to try to plot both of these at once, we can't plot them because those vectors are going to be different lengths. So let's say that we wanted to plot, I don't know, the new cases per day for these two counties. We couldn't plot them together because, again, they have different lengths for the vector. And when we make our plots, they have to be the same length. So if we keep going through here, you can see that most of them have 265. This one has 264. So that's different. And so you see pretty much all of them have 265 though. So we're going to delete the counties that don't have a length of 265 just to simplify the project. Okay, so if I click on one of these, then we get the indices for that specific county. So this is for Alameda. So let's go to our main spreadsheet. So let's pull this out here. So if we look at Alameda, I don't know if I'm saying that right. The last index for Alameda is 265. So if I go to row 265, and we'll see that was the last index for Alameda. Let's look at it for a different county. Let's do it for 18. So 18, that will correspond to Lassen. So let's look at Lassen. That's going to start on row 4493. And scroll down. 4493. Look at that. That's our first row for Lassen. And then it goes to 4757. And that's what we see. So it's working out. Okay, so for some reason, this is a question. For some reason, my counties unique indices is only showing the first column. Okay, well, I'll take a look at that in a second. So if you did it right, though, then all of our indices, they match up for our main spreadsheet. So that's looking good. I can never get this back there. Whatever, I'll close out of it like that. Okay, so counties unique indices. You're having an issue there. Make sure that you put an I here, not a 1. That's a common mistake. not saying you did that, but I do it pretty often too. Because it seems like from your issue that might be why. Okay. Yeah, I do it really often. Yeah. I don't know why. It's like instead of going to I, my finger just goes to 1 automatically. But yeah, it is a common mistake. I know a few students do that pretty often too, and of course I do all the time too. So if you get an issue like that, just make sure that you put an I and not a 1. Okay, so for the other things here, I'm going to have you do them on your own, but now you have this kind of reference for this line of code on 82 for the kind of formatting, and you'll also notice that this is similar for the formatting or kind of style that we had for the last homework as well. So we went over that solution last class, but I also uploaded my script on Canvas too if you want to look at it that way. So after this, you're going to use those indices that you just found here, and you're going to use array addressing to get all of the data for each county here. So for that, we're also going to basically, what I did is, I'm not going to show you the full line of code, but I did counties unique data. Oh, see, I just did it right now. I did a colon and then a 1. Okay, so yeah, we want to make sure that we have I. And then here I used those indices that we just found and I applied them to our county spreadsheet. And then that way, inside of each cell that corresponds to a county, I have a table for all of its relevant data. Okay, so also for the indices, we're supposed to have 1 column or 2 columns. You should have 1 column, but it's a cell array. So I'll share my screen again for that. So these are indices. So first we have our cell array, but inside of each cell, it's just a column vector. Because it's just the indices for that unique county. Okay, so let's go back here. And then after that, you're going to use a logical operator to determine which counties do not have a length of the county's testing range. So remember when I was showing you guys the cell array, we could actually see the length for all of the counties. And there was 2 or 3 counties that didn't have a length for this current data set that I have of 265 or something like that. So whatever it was, you're going to delete the counties that don't have a matching testing range as counties testing range, which we made earlier on as a variable. So you're first going to use that logical operator, so that'll give a 1 or a 0. And then you're going to use the results from that to find the indices when the length for each county was not equal to the length of counties, they should say counties testing range. And then once you find those indices, you're going to delete those respective rows and columns from county's unique data, which we pretended to make here. And then you can just take out those respective counties from your data set. And then we're also going to delete the respective counties from CaliPop. So that's our population spreadsheet. So you're going to delete it from that as well because we want to have a matching length. So let me try to help you visualize this a bit better. Okay, so another question. Can we do that within the for loop or does it have to be outside the loop? You can do it within the for loop, but you don't need to iterate in this case or loop on I. So I did it outside of the loop because it's just, you're not doing anything with your looping counter I. So it's there's no point to do it in the loop. But you technically can. Okay, so remember we're deleting some of these counties like this county here. County number 17, that was Lake. So this length here for Lake is 264, while the vast majority are 265. So we basically need to write some code to first determine which counties don't have a length of 265. This will be one of them. And then we have to find all of those indices in our cell array that we pretended to make, which is called counties unique data. So we would, well, basically we would actually delete that cell. So we would just delete this cell 17. And so yeah, we'd take all of those out, and then we would also need to make sure to delete that respective county from our Cali pop spreadsheet. So we need to take out this row right here as well. And a little hint, you'll see that this is row 17 for Lake, and that was also column 17 for our cell array for counties unique indices. Okay, we have a few questions. So whichever county has a link that doesn't sync, we delete completely. Yes, that's correct. And then Alexander, I'm also noticing that tables within my county's unique data or county's unique indices are 241 or 250 instead of, yeah, that's just because I have an updated data set. Yeah, that's correct. Okay. So let's go back here. So I think that might be the most confusing part of the project, but hopefully you have a better idea now. So it actually shouldn't be too bad, because we just kind of talked about why we're deleting some of these counties, because they don't have the same testing length as the other counties. But this is also somewhat similar to your homework when we deleted some indices as well. So on the homework we deleted rows when we didn't have, when a player had less than 500 plate appearances. So it's similar to that. We're using a different logical operator in this case. I even show you here actually. So I use the not equal to operator. You could do it whatever method you want to use, but personally I use the not equal to operator. Okay. So let's go on here. So you'll see I have some of these comments here that are on your own. So for this stuff here, you can do them on your own. This is easier than what we're going to go over in a second. So here I basically was making a table though. I made a table that was called, for me personally, I called it counties total. And then on each new line here, I added a column. So let me do some pseudocode here. So basically what I did is I started this out by making a table that was called counties total. I won't spoil the rest, but it's counties total. And then I started to append relevant data that I calculated in a new column. So for population, of course, we already know that, but I did, guess I can delete that there. So I did counties total dot population, and I had some stuff after it, so I'll put some dots. But this appended a new column that was called population. And then same thing for total deaths. I did counties total dot total deaths, and then some stuff. And that basically made a new column called total deaths in my table that I made called counties total that showed the total deaths for each respective county. So I kept doing that for all these other things here, and of course we're inside of a loop, so we can do this for each county. And then I had a table in the end that contained total deaths per million, total cases, and total cases per million. Okay, so find indices. Let's do this now. So we're going to find the cell indices for X populous counties. So one of the deliverables that you have is finding results for the top 7 most populous counties. So what we're going to do is find those respective cell indices, so we can get those kind of, I don't know, easy for us to access. Okay, so the first thing that I did, I'm like looking at some of this now, and I could have written some of my code a bit differently, but it's okay. So I'm going to do calipop. Remember earlier I sorted this alphabetically, but now I'm going to sort this by population. So I'm going to do sort rows and calipop. We're going to look at the population column, and we're going to sort it by descending. So this will now make our Cali population spreadsheet sorted by the highest amount of, or the most dense population to the least dense. Maybe I shouldn't say dense really, but highest amount of population to the least amount. Okay, and now we're going to actually find the indices for each of these. This will be referencing our county's total table that we just made. Okay, so what I'll do is for I equals 1, let's actually write this. I'll make a new comment here. So this should be sort calipop by population, and then we'll have find indices from counties total for counties sorted by population. Okay, so what we're doing right now is we're finding the indices for all of the counties and our table that I pretended to make that was called counties total right here. So we're going to find the indices for each county within that table. And this is sorted by the most populous counties. So, this will make more sense once you actually write the code and you can actually visualize this. But it'll be for I equals 1 to the length of calipop.county. So we're finding the index for each county. And then I'll do counties top pop ind for index. And then I'll do I comma 1. This will give us a column vector. And then I'll do find. This time I'm going to use string compare. So remember, string compare, that's faster than isMember. But I can use string compare here since I'm using a for loop. So for each pass, I'm looking at one specific county. So I'm going to do counties total dot county, and then calipop dot county, and then we're going to loop for I. So what we're doing here for the first argument, we're looking at our table that we pretended to make that was called counties total, and we're looking at the column that's called county. And then for each pass in our loop here, we're going to look at calipop.county. So calipop, that's our spreadsheet that contains the population for all the counties. And in the line above here, we sorted that by the most populous counties. So what this will give us is it'll give us the indices for the most populous counties for California. So the first one will be, Los Angeles. Then it'll be, I think, San Diego. So let's run this right now. Oh yeah, this isn't gonna work because I didn't make my my table up here. So what I'll do instead is I'll show you what it should look like for my script. So let me actually open that up. Give me a sec. We called that counties top pop ing. Here it is. Okay. Let's see. Let's open up my table too. Give me a sec. Let me comment out some stuff on my other code. Okay, I'm actually not going to mess with that now. I wrote my code a little different for my code versus what I'm showing you now, just the order. The actual code is the same, but the order is a bit different. But what I'll do is I'll share my screen for something different. Oh, okay, here it is. Okay, so this, if you run your code, it'll show something that's similar to this. It might be different because remember I just said that my actual code, I had some things kind of in a different order, but this is giving us the indices for the most populous counties. It's giving us the indices for the table that we just pretended to make. So what this should be, this first index here, it should be for Los Angeles. So just make sure once you actually work on your code that that's correct. Okay, let's continue on here. Okay, let's see what we got now. So we're probably gonna run out of time. Actually, no, we're actually looking good. Okay, but if we do go over a little bit, you can stay if you want, or if you need to go, then you can do that as well. But we're actually almost done with what I have planned. Let's get all that out. Yeah, so you see here, I said sort by population. Okay, yeah, I actually see. Okay, yeah, we're sorting something different. Okay, I'll actually just do this with you since it's simple. So we're on the rolling stats now. So when I say sort by population, we're actually sorting a different spreadsheet than what we just sorted. So up here on line 126 for me, we were sorting the population spreadsheet by population. But for our rolling stats, we're going to sort a different spreadsheet, which is going to be counties total. So that's the table that we just made or pretended to make. So you do counties total equals sort rows, counties total, and then population, and then descend. So I could have actually already done this before, just thinking about my code now. I could have sorted this by population earlier on when I made the table up in here. And then I wouldn't have had to sort it again down here. Actually, I didn't sort it, but whatever. I could have sorted this by population earlier on, basically. It, of course, doesn't really matter, but I'm just kind of thinking about it as I go here. Okay, so what we're going to cover right now is part of a for loop here. I should have a comment right there. For the rolling cases. So this is going to be, a little more complex than we've gone over so far. And this will be similar to the homework as well. Okay, so the first thing that we're doing is we have for I equals 1 to counties include. So counties include, that was we made that as a variable earlier on. That was for the amount of counties that we wanted to include. So we could also do this really for every county if we wanted. In fact, I would actually recommend that just out of your own curiosity, but that will of course also slow your script as well. So you could keep it like this. You can either do for I equals 1 to counties include, which for us, that's going to be a length of 7. So if I do length of counties include, okay, it's showing 1. I think it's just because of this right here, but earlier on we made counties include should be up here. That should be a length of, or it's saying a length of 1 because this number is a length of 1. But if we do for, we had for I equals 1 to counties include. Let's go back here. So yeah, we have for I equals 1 to counties include, so that'll be for I equals 1 to 7. So not the length of counties include, but for I equals 1 to counties include. So that'll be for I equals 1 to 7. Okay, so the rolling new deaths per day. Let's go over that. So we're going to have counties roll. And what I personally did is I made a cell array once again. But what I'm going to do this time, and yes, that's a 1 on purpose, I'm specifying that I want this to be the first cell in the cell array that we're making. So I'm going to do counties include in curly brackets, colon, comma 1. This means that this variable or the cell that I'm making here is going to be the first cell in a cell array that's called counties roll. And then for each cell within this cell array, I want to have all of the rows, and I want to do it for the ith county. So in this case, we have 7 counties. Then I'll set this equal to counties unique data. So that's something that you had to make earlier on your own up here. So we found the indices, and then you just have to use those indices to get the unique data for each county. So we have equal to counties unique data. And I'm going to put a 1 here because we only have 1 row, how I have this formatted for our cell array. And then we'll do counties top, pop, indices. So this is for the indices that we just found for the county sorted by population. And we want to do for I amount of counties. In this case, that's 7. And then we're going to do dot new count deaths. Maybe I shouldn't have shown you all of this really, because it's a lot of the other things are similar. It's okay. It'll help you out, so it's fine. Okay, so we have let's go over this one more time. So we're making a cell array that's going to be called counties roll. And for rolling new deaths per day, this is going to be assigned to the first cell in this cell array called counties roll. Now, within this cell, I want to get all of the rows, and I want to do for the ith county. So we're going to get all of the values for the new deaths per day for each county. Okay, and then I'm gonna do this for counties unique data. So that's what we're looking at. That's I spelled unique wrong. That's something that we created earlier on in a cell array. Well, we pretended to make it. And we have a 1 here because we just have 1 row for our cell array. And then I want to do for the top, in this case, top 7 populous counties. So that's why we are iterating on I. And then we want to look at .new count deaths. So .new count deaths, that's in reference to counties unique data. Okay, so that's the code for that. I'll actually show you what this should look like though for my code. So we're out of time, but again, I'm going to keep going. So if you guys have a few minutes to spare, I recommend that you stand here, especially for this line of code too. This is an important one. Okay, so I'm going to look at my code and go to, first I'll go to counties unique data. I'm going to open that up. And then we have counties roll. Okay, I clicked on hospitals. Okay, counties unique data. There we go. Okay, let me share my screen for that. Also, the video will be up as soon as I can get it up, so probably in a few hours. It takes a while to process. Yeah. Okay, so we have counties unique data here. So this is what we pretended to make earlier on, remember? So we had all of the indices for each county, and then we would use those indices to apply them to get all of the unique data for each county. So if I click on one of these, this is for Alameda, then we have all of the data. Oops, we have all of the data for Alameda. So this is basically, oops. Okay, there we go. This is showing us all the data for Alameda from basically the counties spreadsheet that's our main kind of spreadsheet. But this is a table here just for Alameda County. So from here, I can access the new count deaths, which is what we did. We made a new cell array that was called counties roll. And within our first cell here, this is going to be data for the new deaths per day for the top 7 most populous counties. So this first column here, this is for Los Angeles. Okay, and then if I keep going throughout here, then we see the new deaths per day for Los Angeles. Right, and then the second one, this is for San Diego. So this isn't a table that I have here. You could do that. In fact, that might be a good idea, but so it doesn't show, that this is Los Angeles and this is San Diego. So you kind of have to do some bookkeeping yourself. So write a comment in your script if you want to kind of help you out, or just keep that in mind what you're actually doing. All right, so let's see if there's anything else I should kind of cover here. I think that's it. So after this line of code that we just did, we would also do it. Hold on, let me. Okay, there we go. So we would also be doing this for other things like the new deaths per day per million. And so that would just be a whole new cell for counties roll. Yeah. So that would be a new cell there. So that would be basically cell number 2 here. This is, for me, I did this as the new deaths per day per million. And then our third cell was the new deaths per day per million on a 7-day average. And then the fourth cell, that was the new cases per day. Then the fifth cell, that was the new cases per day per million. And then the sixth cell, that was the new cases per day per million on a 7-day average. All right, so after that, all you would have to do is then start the next section, which would be the hospitalization data. And again, the workflow for that is very similar to what we just went over today. So there's a few different, different things that you're doing for the hospitalization data, but the workflow itself is pretty similar. So with that, you guys should be good to, to get started on the project if you haven't started yet. Okay, so that was the last class. That's the last time that we're going to meet together. So hopefully you guys found this useful, and hopefully you enjoyed the class too. So, I know some of these quizzes and homeworks and these projects are challenging, and I want them to be challenging, but I also don't want to kill you. But hopefully you've enjoyed the class and you've learned, something that you can actually apply in your future classes and just in general for MATLAB or programming in general. So it was nice to kind of meet all of you. I never really met you in person, of course, but it's good to get to know all of you. So hopefully I see you guys in the future too for a different class. And yeah, so I'll still be around to help, of course, on Discord till your project is due. But this will be the last time that we actually meet in person. So yeah, I'll see you guys. I'll see you around hopefully next semester. But if not, good luck on your finals. And yeah, that's all I got for you today and for the semester, I guess. All right, have a good one, guys.
Thank you for the challenge, Professor.
Yeah, I think you've actually enjoyed the challenges. At least that's the impression I got.